Hi everyone, welcome to day 3 of limits. Today's learning target is I can calculate limits graphically and evaluate limits at a constant. Let's take a look at the first question. Consider the following function defined by its graph. Find the following limits. Why don't you pause the video and try to solve A through E. Let's take a look at the answers. A, limit as x approaches -1 from the left. -1 from the left, it approaches 2. How about from the right? That also approaches 2. Therefore, for C, the limit as x approaches -1 of f of x, because they're both the same, the answer is 2. Next, we have the limit as x approaches -4 of f of x. Notice it doesn't say from the left or from the right, so it's our job to find from the left and from the right. From the right, the limit approaches 4. From the left, it approaches 3. Because those numbers are not the same, therefore, the limit does not exist. And finally, for E, the limit as x approaches 4 of f of x. Again, notice it doesn't say the left or right, so it's our job to figure out if they are in fact the same. The limit as x approaches 4 from the right is -2. The limit of f of x as x approaches 4 from the left is -3. Because they don't match, the limit does not exist. If we look at the next set of questions, it says, how can we evaluate the following? So please try to solve A through D by substituting. Please pause the video before we go over the questions. Take a look at the answers. For A, the limit as x approaches -1 of 5, because there is no variable, the limit is always 5. 5 is the constant. For B, the limit as x approaches -5/2 of -x plus 2. Substitute -5/2 in, and the limit is 9/2. For C, substitute 3 in for x, negative radical 6. And D, substitute pi in for x, sine of pi is 0. Next, you have 8 questions, and it says to evaluate the following. Again, take a few moments, try to answer the questions, and pause the video before we start to review the answers. Here are the answers. For number 1, we substitute 2 in for x, and the limit is 0. For number 2, we substitute 1 in for x, and the limit is 5.5. For number 3, we substitute 3/2 in for x. The limit is negative radical 7. Number 4, we substitute 1 in for x. The limit is 3. Number 5, substitute 3/2 in for x is equal to -18/19. Number 6, substitute 3 pi over 4 in for x, and you get negative radical 2. Now, number 7 and number 8, you might have different answers, and that's okay. There are many different answers to have. But for number 7, give one example of a limit that evaluates to 4. I wrote the limit as x approaches 1 of 4. Remember, 4 is a constant, so no matter what, you're going to get 4. X could have approached any number. And number 8, given an example of a limit of a quadratic function where the limit evaluates to 9. Now remember, it says quadratic, so it has to have an x squared. So I wrote as my example the limit as x approaches 2 of x squared plus 5. If I were to substitute 2 in for x, 2 squared is 4, 4 plus 5 is 9. Again, you may have different answers, and that's good. Next, we're asked to find the following limits using the graphs below. We have y is equal to f of x in one graph and y is equal to g of x in the other graph. So let's do a few of these together. So let's take a look at the first one. The limit as x approaches 0 from the left of f of x. So I'm at 0, but I'm approaching from the left, so that's going to be -1. 0 from the right is 1. Do these two numbers match? No, so therefore the limit as x approaches 0 of f of x does not exist. Let's look at g of x now. 0 from the left is -1. 0 from the right is -1. Therefore, the limit as x approaches 0 of g of x is in fact -1. Try the rest of the problems now and pause the video. Here are your answers to 3, 4, 5, 6, 7, and 8. Notice for number 7 and 8, they have you using an operation. Number 7 is addition, number 8 is multiplication. And 9 and 10 is the same idea. If you have any questions, please feel free to message me on Teams. Hope this was helpful. Have a great day.